Hello students, so welcome back to the new videos. In this new videos we will discuss about a new chapter. This is chapter number 11, works and energy. Okay, so in the previous two video lectures we have discussed about the force, the law of motions, okay, and also we have discussed about the gravitational. From these video lectures, okay, the video lecture will be part into four different parts, and these four different parts of video lecture will try to understand more about the works and energies. Okay, so you see, we know the words that works. What does that works mean? You see, I'm doing a lot of works out here. So I'm trying to produce a lot of like I said, videos lectures. I'm recording a lot of video lectures. Okay, so do you think what does we need? Okay, what does it we need the works? Okay, to do works, and what is the important aspect? What is the important views in terms of science, and what does the science explains about the works? Okay, so you see. Uh, the works that we do in a day-to-day life and the works that related to science is quite different. Okay, we try to explain the science, the works in two different ways. Okay, so in this chapter is another concept that we are going to talk about, a natural phenomenon that is what we call as a works. Okay, so this work is totally related with the energy and powers. Okay, so the works is totally related with the term that is what we call energies and powers. Okay, let's try to understand the works. Okay, let's try to understand first in this video. This part we will only discuss about the works. Okay, you see, in spite of working okay so hard, but still there's not much work have been done. Okay, let me take an example. If I let you to stand, if I let you to hold a sack of rice, okay, a bag of rice on your head, and let you to stand for 1 hour. Okay, uh, after 1 hour you will say, today I have done a lot of works. My sir have sent me to just do this thing that to let me to stand out here. Okay, but I would say you haven't done any works. Okay, now if I let you to push this wall, okay, if I let you to push this wall, okay, if I let you to push this wall, okay, I know that the wall is not going to move, but I will let you to push for an hour or for 2 hours, for 3 hours, or whatever the times, it may be days or times or whatever it is. But if I let you to push these very hours, okay, do you think the wall is not going to move? Okay, but you have been trying for so hard. Do you think the work has been done? No. Okay, according to science, we haven't done any works. Okay, so according to science, what is works that we will discuss? Okay, again, let me talk about. You have been writing a notes for a very long hours. Okay, you're writing a notes, you're watching the videos. Okay, you're watching my video lectures. Okay, now after you going back to your homes and you say to your parents, after in 1 hour, today I have done a lot of works. I have watched the video lectures, but I would say you haven't done any works as per the terms of science. Okay, so what is the works as per the terms of science explains? Okay, as per the terms of science explains that to understand this works, okay, as per the science, okay, works should confine of two different property, two conditions. Okay, the works, if you want to say the work is being done, okay, that means it should be fulfilled two different things. Okay, two different conditions is to fulfill. Okay, the first condition is what? Okay, the first condition is what? A force must act on the object. The force must act on the object. That means whenever you are applying a force, means whenever you are doing a force, that means there should be a force. Okay, there should be a force. Okay, next is what? If the force is there, okay, if the force is there, the object must get displaced. Object must displace. Okay, object must be displaced, means object must move from its initial positions and change its positions. Okay, the object must displace, means the object must change its position from an initial to the new positions. Okay, that is final position we can say. Okay, so object, what does it say? Okay, whenever the work is been done, okay, whenever the work is been done, that means these are the two conditions that we have to fulfill. If these two conditions are not fulfilled as per the science, we cannot say the work is done. Okay, we cannot say the work is done. What is the condition that we need? Force must act on the object. Now, if the object is, this is the object. If the object is the object, okay, if I apply a force on it, okay, then this object does not change its position. That means whatever force I apply, whatever energy that I lost, okay, you cannot say the work has been done. Okay, but if I apply the same force again on this object, but this object displaced from this and reaches up to this position by applying a force, that means the object has changed its position from, it has moved to the new positions. Okay, the object has moved from A positions to B position. That means what? That means we have applied, the work has been done on it. Okay, but if the force is applied on it, but the object does not move, okay, the object does not move, then we cannot say the work is done. Okay, that is why I was relating the same thing. You see, you have been watching the videos on the holidays and watching all the video lectures and studying writing all the notes. Okay, you have applied the force on the object. You might have applied the force on any object, but the object does not displace. So if the object does not displace, if these two conditions are not satisfied, then we cannot say the work is being done. Okay, so any object does not, any one of these conditions does not exist, then the work is not done. If you are applying a force but the object does not displace, that means you cannot say the work is done. Okay, as I told you, you are applying a force on this wall, you are applying a force on this wall, but this wall does not displace, then we cannot say the work is done, then we cannot say the work is been done. Okay, but if I move this, okay, you are applying a lot of force out here. Okay, you are applying a lot of force on this wall. You are applying a lot of force on the wall, but the wall does not move. You have applied, you have lose your energies by applying a force on that wall. A whole day there was a soil on your bodies, but the wall does not move. But you cannot say the work has been done. Okay, I cannot say that you have done a work. But you see, if I just apply the force on it, this object is displacing its position, right? I'm applying a force on this. The object is moving in a new position. That means what? I have done a work as compared to the one who have applied a force on the wall. Okay, so that is what it says. This what is it? In the first condition, whenever you are applying a force on it, okay, on the wall, but the wall does not change. Means what? Object does not displace. Object does not change its position. Okay, does not change positions. Change in positions. Okay, so if the object does not change in position, okay, in the initial position does not change from the initial position, then we cannot say the work have been done. Okay, but if I say even a little force it may be, but the object displaced on it, that means what? I have done a works on it. Okay, so that is what the science is saying. Okay, as per the science terms, okay, the concept of science said, a work must be said to be done. A work is said to be done if the force is applied on the object. Okay, a work is said to be done if the force is applied on the object and the object displaces its position. Okay, when do we say the work is done? We say the work is done if the force is act on the body, if the force is act on the body and the body displaces its position, then we can say the work is done. Okay, so you see, let's try to understand this work done by the constant force. Let's try to derive the formulas of the works. Okay, now you see, let's say this is an object A. Okay, the object is initially at a position of A, and after applying a force, okay, we apply a force on the object. Okay, so let the force applied. Okay, let the force applied on the object. Okay, on the object be F. Okay, and object displaced be S. That means object have changes his position from A to B. That means distance between A to B is S. Okay, you are applying a force on this, then after some while the object reaches up to this. Okay, so therefore work done is what? Okay, therefore work is been done, right? So work done is equal to what? Force into displacement. Okay, force into what is the work done? Work done is always equal to the products of the force into displacement. So what is the work? Work is F, force is what? F, and displacement is what? S. Okay, so work done is W is equal to what? W is equal to F into S. Okay, what is F? It is the force. What is S? That is the displacement. This is what our mathematically we can say it. Work done is equal to force into displacement. Okay, so SI unit of work is what? SI unit of work is what? SI unit of work is what? SI unit of work. Okay, SI unit of work. We can also say SI unit of work is what? Newtons in meters. Newton meters. Okay, we can say Newton meters. Okay, we can say because force, SI unit of force is what? Newton, and SI unit of displacement is what? Meters. Or we also define by the word that is joules. Okay, we also define by the word that is joule. Okay, we also define by the word that is joule. Okay, so SI unit is Newton meters, or joule. Okay, it is denoted by the capital letter J. Okay, capital letter J. It is denoted by the capital letter J. SI unit of work is what? Newton meters or joule. Okay, so when do we say 1 joules of work is being done? Okay, if 1 newtons, okay, I'm rubbing this one. Okay, what do you mean by 1 joules of work? Okay, 1 joules of work. What is the 1 joules of work? In the 1 joules of work, if the force is equal to 1 newtons and if the displacement is only 1 meters, then the work done, okay, work done is 1 joule. Okay, work done is what? 1 joule. Okay, work done is what? 1 joule. If the work force is 1 newton and displacement is 1 meters, okay, we can say, okay, 1 joules of work, 1 joule is the amount of the work done, 1 joule is the amount of the work done, okay, on an object when 1 newton is applied, when 1 newtons of force is applied, okay, to displace the object by 1 meters along the line of actions, so line of actions of the force. Okay, so this is what we said. If 1 newton, 1 joules of newton, what is it? 1 joules of newton means 1 joules of work done is equal to the amount of 1 joules of work done is said. Okay, when you say 1 joules of work is done, when 1 joules of work is said to be done, if a force applied is 1 newton and displace the object only up to 1 meters. Okay, so this is what we call work done. Okay, so we can also what is that? We can also differentiate the work in 3 parts. Okay, 2 parts, that is negative works and a positive works. Okay, so today this works. Okay, so work can be classified into 3 parts. Okay, work can be classified into 3 parts. What is what we call as a positive works, or we can also say zero works. Okay, or we can also say negative works. Okay, let's try to understand one by one the examples. Okay, what is the positive works? If I apply the force on this direction, an object move in this direction. Okay, the object move in this direction. The object is moving in this direction. Then we can see the work done is what? A positive work done. We can say a positive. Okay, so if the force, okay, the applied force and the movement, the displacement are in the same direction. Okay, applied force and the displacements are on the same directions. Okay, applied force and displacements are in same directions, then we can say the object is doing a positive, we are doing a positive work on the object. Okay, that means the object is, let's say, I'm giving the example here. If I apply the force in this direction, the object is moving in this direction. Okay, the object is moving in this direction. That means what? We are doing a applied force. Here, zero force. What is a zero force? Okay, you are applying a force. Either force is equal to 0, or you can say you are applying a force. Okay, you are applying some force to the x newton, but your displacement, the first condition may be something this way. The second condition is what? Displacement should be 0. Okay, so if the work, you are applying a force on it, Okay, you are applying a force on it, but there is no displacement, then the work done is considered to be the zero displacement. Or if you are applying no force, okay, if you are applying no force on it, okay, if you are applying no force on it, no force, 0 Newton, that means this is another condition. If you are applying no force on it, that means what? The work done is also a zero. Okay, the net work is what? Zero. That means what? Some example, like if you apply the force on the, if you try to do a works on the wall, okay, the wall is not going to displace. That means this is the examples of zero works. Okay, next we have another example, that is another type, that is what we call as a negative works. Okay, if you are applying the force, okay, the directions of the force, apply force, okay, apply force, and their displacements are opposite in directions of displacements, okay, are opposite to each other's, okay. That means what? If you are applying a force in this direction but the object is moving in this direction, okay, if the object is, you are applying a force of this direction but the object is moving towards me, then what we call as a negative force. So can you give them some examples of negative, okay, negative force? Okay, your gravitational force, okay, the work done on the object, your gravitational force. Whenever you are trying to pull up, you see, I'm trying to pull up this one, I'm trying to pull up this one, but the force is trying to, that gravitational is trying to pull down, right? So this is what we call as a negative work done on the object, this object. Okay, so the gravitational force is trying to pull down, right? But I'm applying a force, since my force I will consider to be zero, but as the object is flying up, okay, moving on, but the gravitational force is applying. So in terms of gravitational force, okay, the work done on this object will be negative, but when I am applying a force on it in view of me, in my opinions, okay, in my viewpoints, okay, my work done will be positive on this object. Okay, next is another gravitational frictional force. Okay, so when you're moving, when you're trying to slide the object on it, okay, so when you're applying a force in this direction, the object is also moving in this direction, but there is a gravitational or frictional force on this ground between the object. That means the force is applying, the frictional force is applying in this direction. Okay, so frictional force applied on the object, negative work done. Okay, so these are the three different types of negative work done. Okay, so this is all about the work done. Okay, so let's try to understand what is an energy. Okay, let's try to understand what is an energy. You see, the word energy we often use. What is an energy? What is an energy? Okay, I have an energy, you have heard about the words energy, right? So we'll discuss details about the different types of energy, but today we'll discuss only the some types of energy, and at last I will try to do one numerical problem, then we'll end up this video lecture for the first part. Okay, so what is an energy? Okay, the energy, what do you understand by the words energy? Okay, you have heard about this. What is energy? Energies. I have a lot of energies. I have a lot of energy, right? What do you mean by the energies? Okay, so energy is, according to science, defined it. Okay, so capacity of doing works. Okay, what is it? Capacity to do some works. Okay, so energy is what? Energy. Okay, capacity to do work. Capacity to do works. Okay. The energy is what? Is the capacity to do some works. Okay, if you're trying to do some works, okay, so if you're trying to possess some energy, some work, then we can say, okay, the energies. Okay, so SI unit of energy is also considered to be the SI unit of energy is also denoted by SI unit is energy is also denoted by joules. Okay, SI unit of energy is also denoted by joules, that is capital J. Okay, this is small letter joule. Okay, so SI unit of energy is also denoted by joules. Okay, so 1 joules of energy is required to do 1 joules of work. The same large energy is called as a, okay, this is a, and the large energies of SI unit of energy is what we call as the large energies of large SI unit of largest SI unit is what? SI unit we consider this as kilojoule. Okay, in the biggest form we define as a kilojoule. Okay, that is K and J. Okay, so SI unit, the SI standard unit is what we call as a joule. Okay, so what is energy? Energy is the it is a energy which is what is it? is the capacity to do some works. Okay, is the capacity to the process, and the energy processed by object is then measured in terms of its capacities of doing work. The unit of energy is therefore the same as that of work, that is joule. 1 joules of work is said. Okay, 1 joules of energy. Try to understand it. There will be two questions. 1 joules of energy, 1 joules of energy, and 1 joules of work is different. Okay, so 1 joules of energy is what? 1 joules of energy is defined as the 1 joules of energy is defined as the energy required to do 1 joules of works. Okay, what is the 1 joules of energy? 1 joules of energy is defined as the energy required to do 1 joules of work. And 1 joules of work is what? 1 joules of work. 1 joules of work is defined as the amounts of work done. Okay, amounts of work done. The energy applied, the amounts of work done in which the object applies in which the force applies is 1 newtons and the object displaced for the 1 meters. Okay, so these are different types of energy. You see, there are different forms of energies. Okay, gravitational, kinetic energy, potential energy, internal energies. Okay, and mechanical energies, frictional energies. Different forms of energies are there. Okay, in our universe. Okay, but we are going to discuss only 2 energy. What is what? Potential energies and kinetic energies. So potential energies and kinetic energies that we will discuss in the next video lectures. Okay, so one by one we will discuss about the potential energy. In the next video I will directly start with the kinetic energy and then continue with the potential energy. Okay, so here we will discuss this is what is energy. We have learned about energy, we have learned about the work done also. Okay, now let's try to do one numerical problem. Okay, last numerical problem. Okay, so one numerical problem is what? The first question, that is page number 160, question number 4. A pairs of block exert a force. Okay, you can refer page number 160, question number 4. A pairs of block exert a force of 1 newtons on a plow. The fields plow 15 meter long. How much work done on the plow of the field? Okay, so question number 4, you see, it is very easy. It is very easy to solve. Question number 4, given. Okay, force is given. Force is given, F is given, how much it is, S is given 140 Newton. Okay, and displacement is also given. Displacement S is also given, what is it? 15 meters. Okay, 15 meters. So, how much work is done? We know that work done. We know that work done is what? We know that work done is what? Equal to F into S. So which implies that F is what? W is equal to F is what? 140 and S is what? 15. Multiply these two. So this will be Newton meters. Okay, multiply these two. 140 into 15. So 5 4 is a 20, 2 in 5 1 is a 5, 6, 7, 0, 4, 1. So 0, 0, 11, 1, 2, 1. How much is this? 2100 Newton meters, or you cannot say 2100 joules. Work done is how much? 2100 joules. Okay, so in this way we'll try to solve. Okay, so this is all about the work done and energies in this video lectures. So we'll try to meet up next video lectures about the kinetic energy and potential energies.